Right, the word geometry is Greek. Geo means earth and metry. It's actually from the metric. It means, or metria, means measure. And what it is it's the study of the properties of space and their relationships. And that's 1, 2, and 3-dimensional space. We study what's called Euclidean geometry. And Euclidean geometry was created mostly by the Greeks, and it was put together in a book by a mathematician named Euclid. He didn't invent it all, but he did compile it all, and he wrote the first geometry textbook. And he wrote that in 300 BC. You don't need to know that, but it was called The Elements. It's all about geometry. And most of the geometry you ever deal with, I would say 99.9% of the geometry you ever deal with is Euclidean geometry. There are non-Euclidean geometries, but you usually only deal with those if you go into higher levels of math or engineering. So what we have points, lines, and planes. They are described but not defined. And that's a very subtle difference. We can tell you what they look like, but we can't really define a point. Like it's a point in space. It's like a little tiny something out in the middle of space. So it's not really defined, but it is described. And a point is a location. It's just a location, and it's represented by a dot. And we give them letters. So that's point A. It's not really a dot. A point is technically smaller than a dot, but we wouldn't be able to see the size that a point actually is. So we make it a dot. A line is an infinite set of points. So what we have is a line is an infinite set of points. Lines are infinite. And even if you take the smallest little piece of a line, like that, that's the line segment. It's not really a line, but if I take that little tiny piece of a line, that piece of a line has an infinite number of points in it because points are infinitely small. So what we do is we call the line based off of just randomly 2 points. So we call this line here, I can put an M in front of it, so that's either line M, not line, sorry, line M, or you can call it line AB. Okay. And lines go forever in both directions, so it has to have the 2 arrows on the end. If it doesn't have 2 arrows on the end, it's not a line, it's a line segment or a ray. And a plane is another infinite set of points. So a plane is another infinite set of points. But okay, so a line goes in two directions. So in this case, right and left. But a plane goes in all directions. So plane is essentially, if you took a piece of paper and then that piece of paper expanded out, it stays flat, completely flat like a piece of paper, but it expands out and it's like a giant sheet forever and ever. If that makes sense. It just keeps growing and it stays flat, but it just grows forever and ever, and that's a plane. And we draw them like a parallelogram. And we can either label them with 3 letters and call it plane ABC, or you can call it plane M and just have 1 letter being labeled. And A, B, and C are actual points on the plane. M is just this name that we gave it. Okay, so we have space. Space is simply the set of all points that ever have been or ever are going to be, ever were. So it's a set of all points. A theorem is a statement to be proven. So there are theorems and there are postulates. A theorem needs to be proven in order to be true. A postulate is a statement that is accepted as true without proof. Just a not very good example, but a postulate would be, I am your math teacher. Do you guys accept that as true without me proving it? Yes. Okay. But maybe the theorem might be that I am qualified to teach all levels of math. Well, I might need to prove that, because there's a lot of levels of math, right? So maybe you wouldn't take that necessarily. You might be, well, you're teaching high school geometry. Maybe you're not qualified to teach, you know, doctoral level math classes, right? I'd have to prove that. And the truth is I'm not qualified to teach doctoral level math classes. I am qualified to teach high school and college, but not that high. Okay, between, sometimes I feel silly defining this, but it's in the space between two things, or that separates two things, or it can be through. So it can cross through but not still stay there. Intersections. Intersection is to cross each other, but it's also the set of points that 2 or more figures have in common. So let's say I have here 2 lines that are intersecting at a point. They're intersecting at a single point. Okay. And I could have 3 lines, 4 lines, 5 lines. I could have a whole bunch of lines that go through that point. And that would still be an intersection, and it would still be one point. Here I have planes, and planes don't intersect at a point. 2 planes don't. 2 planes intersect as a line. Now I could put a 3rd plane in there and I could make them intersect at a point, or I could have another plane and intersect at that same line. But the intersection would be all of the points on that line where they're intersecting. Okay, so a ray is a straight line that extends from a single point. They only go in one direction. They're infinite in one direction, but then they have an end. So that's ray AB. Now when you're naming a ray, if I start at A and go through B, that's ray AB. If I were to start at B and go the other direction through A, that would not still be AB. Because the order that you put the letters in gives you your direction. This would be ray BA. Okay, so that's important. You want to make sure that the end point is the first letter, and then the next letter is the next letter you go through, next point you go through. A segment is any finite piece of line, just a little chunk of line or part of a figure that's marked as separate. So segments have endpoints. There's 2 of them. Endpoints are the points where they stop. Segments have 2 endpoints. Rays have 1 endpoint. And length is just a measure of how long something is. A line and a ray do not have length. Lines and rays go on forever. Rays go on forever in just one direction, but they do go on forever, and lines go on forever in 2 directions, so you can't measure how long they are because they don't have a length, because it's infinity. Segments have lengths, though. We can measure segments. And we can measure, you know, tables and stools and floors and things like that. Anything that ends, we can measure the length of. We just can't measure the length of a line or array. Okay, so I have collinear. Co means together. Cooperation. You're performing operations together, cooperating. Collinear, so together. So collinear points are points that are on the same line. And then non-collinear points are not on the same line. Coplanar are points that are on the same plane. Non-coplanar are points that are not on the same plane. So in this example, A and B are coplanar, but A and C are non-coplanar because they're not on the same plane. Coplanar lines are lines that are on the same plane, and non-coplanar lines are lines that are not on the same plane. Okay. So these are postulates, and from our definition, these are statements that are accepted as true. We do not have to prove them, they're just truth. So a line and a plane each contain an infinite number of points. Well, the description of a line is that it is an infinite number of points strung together, and the description of a plane is it's an infinite number of points. So that's true. For any 2 points, there's exactly one line containing them. Well, we don't have to prove it, but I can show you that it's true. If I have a point here and I have a point here, lines are straight. So there's only one straight line that can connect those 2 points. So there's only one line that exists that will go through those 2 points. So that's true. For any 3 non-collinear points, there's exactly one plane containing them. So if I have a point here, and a point here, it's kind of hard to draw. But if I have this plane contains those points, I could draw another plane that comes like this, but it won't contain this point because it'll only be going through those 2. So there's only one plane that will contain all 3 points that are, if they're not on the same line. Okay. If 2 points are in a plane, then the line containing them is in a plane, and that's true. If I have a plane and I have 2 points, and I draw a line connecting them, that line is also in the plane. And then if 2 planes intersect, they intersect in exactly one line. Well, I'm not going to draw that, but we already had that picture right here. 2 planes are intersecting, and they're intersecting in a line. Any questions on those definition or postulates? I have 2 in this class. So geometry is about, like I said, it's visual. It's about pictures. So it's about the definitions and the postulates and the theorems, and it's about pictures. So a lot of times when you're trying to solve the problems that are presented to you in geometry, it helps to draw the picture. And so if I want to say point Y is on line PQ, which is in plane T. Okay, well I need a plane. And my plane is plane T. Okay, and point Y is on line PQ, so I need a line PQ. And point Y is on it. Now it doesn't say it's between it. It can be anywhere on that line. I could have drawn it on the other side of Q or on the other side of P, or it doesn't matter. I just need to be able to say that point Y is on this line in this plane, and the plane is plane T. Usually when you're naming the letter of a plane, you put it in the bottom left-hand corner. Okay, so you should be able to do that. And then that helps you to visualize the problem, because maybe they say point Y is on line PQ, which is in plane T. You know, if point X is here, you know, they'll give you a scenario. So if you draw the picture, you can then answer the question. Geometry as well. Okay, this symbol here tells us a line. If it has 2 arrows on it, so this is line LM. Okay, that's line LM. But if I saw this, where it's one arrow, that tells me it's array LM, and that it's L is the endpoint, and M is another point that it goes through. Or if I have just a line like that with no arrows, that tells me segment LM. And the L and M are the two endpoints of the segment. And then just to recap, if it's ML, that means that my endpoint, if I kept L and M in the same direction, that would mean my endpoint was at M, and I went through point L the other direction. Okay, so with array, whichever letter comes first, that's the endpoint, and then the next letter is tells you the direction, so which the other point it went into. Okay. Questions on that? A statement that is accepted without proof is a postulate. So you're going to have some vocabulary. Sketch and label a plane containing these 2 points. Well, a plane is a parallelogram. I'm plane W, and I have 2 points. And it really doesn't matter where you put them, just as long as they're in there. 2 lines intersect at a plane. Well, I've got 2 lines. Are they intersecting at a plane? Two lines will intersect at a point. An interesting thing about intersections can only be beneath you in dimensions. A line is one-dimensional. A plane is two-dimensional. A point is zero-dimensional. So in order to intersect and get a plane, if a plane is two-dimensional, it has to be three-dimensional objects that are intersecting. Or a plane. I guess that's not true. You can intersect it, like you can have 2 lines intersect that are completely overlapping and intersecting at a line. So it has to be its own dimension or lower. You can't have 2 lines intersect and get a dimension that's higher. Okay, and then 2 lines intersect at point H. Well, we already drew 2 lines intersecting. That's easy. And they're intersecting at point H, so we just draw a dot and you label it H. Distance is the extent of space between 2 objects or places, and distance and length can sometimes be measured the same. You know, if it's from here to your house is 1 mile, that's the length from here to your house, but that's also the distance from here to your house. But they're not always measured exactly the same. Congruent are figures that are exactly the same shape and size. They're identical in every aspect. And the symbol for congruent is this equal sign with a squiggle over top. Okay. To bisect is to divide into halves or 2 equal parts. So if you cut a pizza in half, you've bisected it. Bless you. A segment bisector is a point, line, segment, or plane that bisects. So it cuts a segment into half. Now I can cut a segment in half. I cannot cut a line or array or plane in half because, well, they're infinite. So I can't really cut it into 2 equal parts because there won't be, you know, there's no way to deal with that because it's infinity and you can't have infinity. Half of infinity is just infinity. It just keeps going on. An ordered pair, or coordinate is an ordered pair that give you the position of a point relative to x, the x and y axis, and you guys have seen these, so like, it looks like that. Okay. Number lines are basically it's a visual representation of the order that numbers go into, and normally we draw a number line with just the whole numbers on there, or positive and negatives. But in between 0 and 1, there are an infinite number of numbers. There are all the fractions and all the decimals, and there's every fraction and every decimal in between all of these numbers that are there. It's just that would be an impossible thing to try to write. So just know it's also all the fractions, all the decimals, all the irrational numbers, everything. To measure something is to ascertain its dimensions. So we can take length, volume, weight, anything like that, mass. Wow, that's weird. And the midpoint is the point at the center of an object. I guess I'll just leave that there. It's the point at the middle or the center. It's equally distanced from the two ends. And you know what a ruler is? Okay, the ruler postulate, so we don't have to prove it, is that the points on a line can be paired one-to-one with real numbers. So we can make a number line. And that the distance between any 2 points equals the absolute value of the difference of their coordinates. And that's kind of a confusing way to put it. But if we take for A, that's just our number line, right? 0, 1, 2, negative 1, negative 2, forever and ever and ever. But for B, if I take these 2 points, if I say this is 0, and I want to know what's the distance between them. Well, if I put, okay, let's just say those are their coordinates. So B is going to be equivalent to negative 4, and A is going to be equivalent to 6. The distance between them is their absolute value of the difference of their coordinates, but that's really confusing. If you always take the larger number, so we always do the greater or larger number, so greater minus lesser. Okay, so in this case, 6 minus negative 4. So if you always take the biggest number, so the one furthest to the right, and subtract the one to the left. So minus a negative becomes a positive. So this is 6 plus 4, so that's 10. So the difference between 6 and negative 4 is 10. The distance is 10. Units. We don't know what units they are. They could be feet, millimeters, we don't know. But if you always take the larger number and subtract the smaller number, you don't have to worry about the absolute value stuff. But distance is always positive. So if I had done negative 4 minus 6, I would have gotten a negative 10. You can't have negative 10 distance. Distance is always positive, so it would have just been positive 10. Okay. Segment addition postulate is if I have a segment A and C, and B is between them, the length of this portion here, AB, plus the length of this other portion, BC, equals the length of the whole thing. Again, that's a postulate because it makes sense, right? The one part plus the other part equals the whole deal. Okay. And then the midpoint postulate is that a segment has exactly one midpoint. Halfway is halfway. There's only one halfway. So if I have a segment that's about halfway right there. If that's the midpoint, like the midpoint's not going to be over here, or there's only one point that's right in the middle. And again, that's one of those things that kind of makes sense. There's only one spot that's in the middle. Hopefully. Where is my... Okay, so what do we use this for? Well, the ruler postulate. If we find the distance between 2 points A and B with coordinates of -3 and 7, we can calculate the absolute value of the difference of their coordinates. We don't have to do that. Like I said, we take the larger and we subtract the smaller. So we're going to take 7 minus -3. That's the same thing as 7 plus 3. So again, the distance is 10 units. Or if you want, you can go to the number line and you can label -3, and you can label 7, and you can count how many spaces between them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Woohoo, 10. Okay, AC. AC is AB plus BC, right? AB plus BC. So if AB is 6 and BC is 2, AC is 8. And you probably would not even have to write all that out. Any questions on that one? Okay, BD. BD goes from here to here. So I have 2 and 7. And then AD goes from here all the way to there. So I have 6 and 2 and 7. Questions on that? We're being told that Q is a midpoint. Okay, midpoint is equally distant from each end. So because Q is a midpoint, that tells me that PQ will be the same length as QR. And that's because Q is a midpoint. So if I want to find X, what I can do is if PQ is equal to QR, that means 2x minus 5 is equal to x plus 3. These two things are equal. And so if I subtract x from both sides, I get x minus 5 is equal to 3. And then I can add 5 to both sides. And that gives me x is 8. So I found x. And let's say I want to find PR, right? So it said to find x, and then it said to find PR. Well, because, again, Q is a midpoint, that means PQ and QR are the same length. So if I find one of them and then multiply by 2, does that make sense? Or I can do PQ plus PR. So I can either say PR is equal to PQ plus QR, or I could do 2 PQ, something like that, since they're the same length. Which would you prefer, adding or multiplying by 2? No, it's not 16 though, because x is 8. But this is x plus 3. Actually, it would probably be easier than to do 2 times QR. Okay, right? Because if this is at 8, x plus 3 is, right? So PR is 22. So I can either find both of these and add them together, or find one of them and multiply it by 2. Does that make sense? And if you come over here and you plugged in 8, you'd get 16 minus 5, so this is also 11. And that way you know you did it right.